Hello everyone, welcome to switispeaks official YouTube channel. This is System Verilog Essential series where we are learning complicated System Verilog concepts which people find very hard to understand. We are trying to cover all those concepts in very simple and easy language. I'll explain you each and every concept, and we will also see a lot of coding examples so that it will be very clear for you. Today we are covering one such topic, which is Modport. Now, one request which I have is this Modport is a continuation of interface. To understand Modport, you should first understand interface. Interface is already covered in detail in the previous video tutorial. If you see, it is uploaded in switispeaks official YouTube channel under System Verilog Essential series only, the previous lecture to this, which is interface. Please go through that in detail and then come to Modport, because Modport is actually a part of interface, but to explain it properly, I have taken it as a different video lecture because I want to cover this also in detail. Our aim is to understand each and every concept in detail, in depth, because we are not just learning for the sake of getting a job or something. We are people who want in-depth knowledge of everything. That's why if I feel that some concept requires 2-3 sections to be properly conveyed, like to get an in-depth understanding, so I'll segregate into 2-3 different video tutorials, but we will cover everything in detail. Now let's start with understanding about Modport. First, we will understand what is Modport. We had already gone through interface. Now in interface, you would have seen that we don't specify the directions. We just say all the signals inside the interface are logic. We don't give anything, input, output, we don't say anything. So Modport is what? It is a sub-entity of interface. It is a part of your interface only. And the purpose of this Modport is to define the direction for your signals. Whatever ports or whatever signals are present inside the interface, we will define the direction for those signals. This is done by the Modport. So the main purpose of Modport is to specify the directions for your interface ports. You should note some things. If any of the Modport wire is declared as an input, if anything inside the Modport you declare it as input, then you cannot drive or assign to that particular wire because it is input. So you cannot drive or assign. This you should take a note. What happens if you do that? If you do that, it will result to a compilation error. That's why don't drive or assign any inputs, because these are inputs. You can drive or assign outputs. You can't drive or assign inputs. Next important thing to note is there is no restriction on the number of Modports an interface can have. It depends on your requirement. If you want 2, you can keep 2. If you want 3, 4, as per your requirement, your design and test bench requirement, you can have any number of Modports. Next thing which we will understand is, why do I need Modport? Why is it necessary to specify the directions of signals inside my interface? Main aim of Modport is to specify the directions of the signals inside your interface. Why is it necessary? Let us understand. First very important point you should understand is, we are not specifying any direction of the signal inside the interface. By default, it becomes in-out. It can be input as well as output because we are not specifying any direction. So that's why by default, it's an in-out. The next important point is, any module which is connected to the same net, because it is in out by default. So it can either drive values from it or it can take values from it. Both things are possible. Drive values from it or take values from it. Because it is in out, it can act as input as well as it can act as output. So it can drive value or it can take value from it. In such scenarios, it means there is no restriction on the direction of the value propagation. It can be inward or it can be outward, input or output. In such cases, you can end up with a situation where you will get X value because both test bench and design are driving two different values to the same net. It is possible. Even your test bench is trying to drive, even your design is trying to drive, and both are trying to drive different values. If such scenario occurs, because there is no restriction to the direction, so design can also give any value, test bench can give any value, and then you can end up with the X value. Such situations can occur if you don't specify the direction. That is why we require Modport to avoid such situations. Next, let's understand about the Modport ports. Your Modport ports can be input, it can be output, it can also be in-out. One scenario is it is possible that your data signal can be in-out. So some signals can be in-out. That's why even in Modport you have the provision to specify some signals as in-out as per your requirement. And you can also have a reference. All these four are the possible directions, you can say, for your Modport ports: input, output, in-out, or even reference. Now let us see how to declare a Modport. The declaration goes something like this. You have to give the keyword Modport. You have to specify name of your Modport, then input, and whatever ports you want to specify as input, you can give all those ports. You can separate them by comma and give all those ports. Whatever you want to specify as output, you can give all the ports by separating them with comma. So this is very simple way to declare your Modport. Next, let's see some example of the Modport. This is one of the examples of the Modport. I have the interface INTF. It has four different ports. It has ACK, grant, select, and IRQ0. I am specifying two different Modports. One is Modport DUT0 and another is Modport DUT1. Now I have four different ports. In the first Modport, which is DUT0, I want to keep ACK and select as inputs, and I want to keep grant and IRQ0 as output. In the second Modport declaration, I want to keep ACK and select as output. Here, if you see, ACK and select are output and grant and IRQ0 are input. This is my requirement. So I'm specifying the directions of all the ports inside interface in two different Modports as per my requirement. Let's see one more example. Here what I am doing, I have a module DUT0. In that I am passing intf.dut0. If you remember, we had seen DUT0 was one of the mod ports. One of the mod ports of my interface intf, and the name of the instance is intf_i. Similarly, I have a module DUT1 in which I am passing the mod port. Here I am passing a different mod port intf.dut1. Both these will have different directions of your interface ports. And then I have a test bench in which I am creating an instance of the interface. I am creating instance of both the DUTs. I am giving the instance name of the DUT and I'm giving dot star. Now what this dot star will do, it will connect all the design ports to the relevant interface ports. You don't need to connect one by one. Dot star means it will match the names and it will connect by itself. You don't need to do it manually. This is one way in which you can connect all the ports of your module to the interface mod ports. This is the mod port. So in this, what happened? Test bench is providing whole interface object to the design. Here, if you see this complete interface object, this is the instance of the interface, complete interface object I am passing and specifying this particular is the mod port. And then the design is taking correct mod port definition from the interface object. Design is design responsibility to take the correct mod port definition. Finally, our aim is that correct port should be connected to correct port. For example, in this module also there will be 4 different ports. So ACK of this particular module should be connected to ACK of this particular DUT1 mod port of the interface. Similarly, select should be connected to select. If you give dot star, this is taken care. This is one way in which you can connect your design ports to the mod ports. Let us see one more example. In this, what is happening? You are not passing the mod port. You are not telling the mod port. You are directly passing the interface and the instance of the interface in both the DUTs. DUT0 as well as DUT1. Then inside your test bench, you are creating an instance of the interface. You are creating an instance of both your DUTs. DUT0, D0 is the instance of your DUT0. And now what you are doing, you are connecting .intf_i. This is the instance of your interface, this instance. And here you are connecting the mod port. You are connecting intf_i to intf_i.dut0. So this is your, here inside the test bench you are connecting. In the previous example we saw inside the DUT declaration itself we are connecting. Here inside the test bench we are connecting. This is also a possible way. And here what we are doing, the test bench is providing the correct mod port values to the design. Here if you see, the correct instance is provided in the test bench, not in the design. Earlier we were passing the correct object with the correct mod port in the design. Now we are specifying that in the test bench. Both are correct ways. And here the design will accept whatever bidirectional value is given to it. It means depending on whatever directions are specified inside this mod port which you are connecting inside your test bench, depending on that, the DUT will accept it. So both the ways are correct. Either specify it in the test bench or design, but you have to specify it somewhere. Somewhere the direction should be decided. This is important. Now, what are the advantages of using the mod port? One very good advantage is we are restricting the direction of the ports. By this, what will happen? We will avoid driving the same signal by design and test bench. We had understood if the same signal is driven by both design and test bench, we can end up in the X value. But if we use mod port, we specify the correct directions. This condition can be avoided. The next important advantage is, depending on your requirement, you can have multiple mod ports. Whatever flavors you need, whatever flavors of different directions of the ports you need, as per your test bench, as per your design, you can have that many mod ports. There is no restriction. So different mod ports for the different directions, for if you want for monitor, for driver, even you can have multiple monitors, multiple driver. If you require different directions, you can specify that. These are the advantages of mod. Now with this, the Modport concept should be very clear in your mind. Please go through this tutorial very properly. All the examples also I have tried to explain it in very easy language. We will continue with some more examples of interface. We will also cover virtual interface in the upcoming lectures. To stay tuned to such content, please subscribe to Switispeaks official YouTube channel. Thank you.